All right, good noon, everyone. Afternoon, everyone. Thank you for joining me. This is Sean here at Zyxel Networks. And today we're doing a sort of a high-level overview of our wireless access points. There's been a number of changes to our wireless access point lineup this year, including the launch of a number of new access points in the last month or two. So I thought it'd be a good idea to sort of, do an overview of what's going on, what products we have, because we've certainly got a lot of different access point models, and give you guys a chance to ask questions on that lineup. So as we go through today, feel free to use chat or Q&A to send in any questions or comments you have as we go through it. I'm going to start by talking about some of the technology in our access points that may be a little bit different than other vendors' access points that you've used in the past. So the first thing we have here is what we call RF first by design. So this is something that sets us apart from a lot of our competition, including some of our much more expensive competition out there. And it has to do with the way we design our access points compared to how most of our competitors do things. So this is applying, as the name RF first implies here, that it's a focus on RF performance. But this also throws in there a focus on longevity of the products themselves. So sort of throw those both in together. So on the longevity side of things, we do not use any electrolytic capacitors in any of our access points, only solid state capacitors. And the reason for that is when it comes to a solid state product like an access point, one of the leading causes of failure over time is failures of those capacitors. For those that don't know, there's a little wound up aluminum strip mixed with some electrolyte and some other medium in there. In a regular electrolytic capacitor. And unfortunately, over time, those can leak or dry out, causing failure and failure of the device. So by eliminating that, we've eliminated the number one cause of failure. The second most common cause of failure on an access point or other solid state component is heat fatigue. Um, so we put a lot of effort into making sure our products are pulling the heat off the board and then dissipating that heat out. That often is going to be a metal heat shield that goes behind the main PCBA to draw the heat off the board. In the case of something like our WBE 660S, the entire back of the housing is a heat sink. And for the other products, you'll also see, in addition to the heat sink that's inside, you will see a lot of vent holes. If you compare us to some of our cheaper competition, you will notice they not only do not have any sort of larger heat sinks for the components, they don't have any vent holes to allow the heat out. So that's why some of our competition is only offering a 1 or 2 year warranty when we can offer a lifetime warranty at the same price point. Excuse me here, my allergies are going nuts with the rain that we've been having recently here in Southern California. Um, I know my allergy. Anyone who's been to these webinars know my allergies are just a constant pain. Anytime the weather gets kind of weird or good. So anyways, back to the topic on hand. So the RF first design itself. One of the big changes that we do is we tend to have a lot more shielding on the components on our PCBA than our competition. I know we used to go at trade shows and have, a Ruckus and a Ubiquity access point and our access points opened up. So you could look at the inside. Unfortunately, all those demo units get beat up going from show to show and event to event. So I don't think we're carrying them around with us that often anymore. And that was one of the things you would notice. And part of that has to do with just general EMI shielding. But the other thing we do is we put in 4G and 5G shielding, which most of our competition doesn't. And you say, well, why would I want that? And the answer is a lot of 4G and 5G signals are operating on frequencies that border the Wi-Fi license-free signal spectrum and do have bleed over, especially if you're deploying access points inside a building that uses a DAS system. So for those of you that don't know, cellular signals don't do a particularly good job of penetrating buildings, especially larger buildings or buildings that have metallized windows. So for those bigger buildings, what they do is they use what's called a DAS system, where they put some antennas up on the roof or they hardwire connect to a fiber network that's linked back to the carrier, and then they rebroadcast the cellular signal inside the building. So they'll be using the same cable runs and drops that you're using for your Wi-Fi and are putting up what are essentially cellular access points next to your Wi-Fi access points where they can cause interference. So that's why we have that 4G and 5G shielding. The other thing you will notice on most is that we don't put the antennas onto the main PCBA like our competition, even our more expensive competition. On most access points, those antennas are mounted on their own separate PCBA that's separate from the main board. And there's very often a large metal RF shield between the two to help create greater isolation on our antennas. So it doesn't do a lot when you've got a strong signal, but it makes a huge difference on those edge cases where the signal coming back from your client device is very weak, or there's a very poor signal to noise ratio. This extra little bit of shielding and isolation for our antennas can make a huge difference as far as the reliability of that edge case connection. Moving on from there. Um, yes, we've got a number of technologies that are part of most, if not all, most of our access points here. So that includes things like smart mesh, the ability to create a business class mesh network. So not all of your access points have to be hardwired, including the ability to fail over should something happen to the hardwired connection. Support for the latest in security, including WPA3 Enterprise, support for all of the main roaming standards out there, 802.1, KVNR, the ability to do traffic shaping, the ability on our access points for the access points themselves to host a captive portal to provide their own NAT on a per SSID basis, and the ability to deploy various different types of security services directly on the access point itself. And with ProPack and Nebula, you have access to a number of AI features to help troubleshoot and monitor your wireless network. So we also have some different antenna technologies that you may not have seen before. So the first one is what we call dual optimized antennas. So most of your access points are designed to be mounted on the ceiling, pointed down at the area underneath it, and they radiate out the signal in an omnidirectional manner. You'll also see this referred to as umbrella coverage. And that's what almost every access point you see out there does. The challenge is that out in the real world, you don't always get to mount your access points on the ceiling, and sometimes you have to mount them instead on the wall where you've rotated the access point 90 degrees from what the antennas that are in there have been optimized for. So you end up in a situation where you end up shooting signal up into the ceiling and down into the floor. So you're getting worse coverage than you expected. And in a multi-floor building, depending on those types of floors, you may be causing interference between the different floor layers. So our solution to this is a number of our access points offer what we call dual optimized antennas. So with a dual optimized antenna, as the dual implies here, instead of having one antenna set in there that's optimized for ceiling mount, we give you two different antenna patterns in there, and you can choose which set of antennas to use based on where you're mounting that access point. So one antenna setup that's designed and optimized for ceiling mount, and another one that's optimized for wall placement. The other technology we have is smart antenna. And unfortunately, for whatever reason, we didn't um, give it its own unique trademark name. So there's a number of other companies calling, anything they want smart antenna. So our smart antenna solution, if you've done anything with Ruckus and their BeamFlex Plus, it's a very similar technology to that. So if you're familiar with that, you're probably familiar with our smart antenna. For those of you that aren't familiar with it, it's an antenna technology that's designed to increase capacity. So more users on the same access point, but also reducing interference, allowing you to have more access points and users in the same area than you would otherwise be able to do, and to increase coverage. And the way it works is instead of having a single antenna pattern like a traditional access point, or having two antenna patterns like our dual optimized access point, those with our smart antenna technology have an array of antennas. The number exactly is going to change based on which specific model we're looking at. But basically, you have hundreds of different antenna patterns that can be used by the access point. And our technology takes into account two different factors: where the client is in relationship to the access point, and where other sources of RF interference are, including other access points operating on the same channel, are in relationship to the access point. And then it chooses an antenna pattern that's optimized for those two factors. So it helps focus the beam towards where the client device is, while at the same time being able to ignore interference. So in cases where you have a dense RF environment with a large number of access points, you quickly run out of RF spectrum and you end up having overlapping channel usage. So with smart antenna, you can actually achieve greater than 100% airtime utilization on your channels in a multi-AP environment because the smart antenna will allow multiple access points to broadcast at the same time without interfering with each other. So it's a really cool technology for those more challenging environments, um, as well as anything where you've got a lot of users or a lot of access points. And the great thing with smart antenna, it's not the same thing as beamforming. Um, it will work hand in hand with beamforming, but the cool thing with smart antenna is it works even on mobile users. So as the user roams around, it will automatically update based on the user's current location and the current environment. All of our access points come with some version of this multi-mounting bracket you see here on the screen. So you mount the bracket to where you want the access point to go, and then the access point slides in and snaps into this bracket, securing it. And then you have to reach in with a screwdriver or a chopstick to release the access point to remove it, making it hard for, if you're doing hospitality deployments for guests or employees of the business to accidentally remove the access point and walk off with it. So this mounting bracket itself is designed for wall mounting, for ceiling mounting, and has screw holes automatically placed in it, designed for various types of junction boxes and outlet boxes that you commonly encounter out in the field. In addition to that, we sell optional T-bar mounting brackets. So you buy a pack of 5, so it gives you 10 actual brackets. You use 2 per access point. So you mount those on the T-bar that holds up your drop ceiling. You screw the mounting bracket into those, and then the access point again just slides into place. So enough with the technology. Now let's talk about the different products that we have. So we try to break up these models into 3 main categories. What we're calling the Simplicity series here. That's our NWA 50 and 90 series access points. And these are aimed at sort of the Soho prosumer type of space. Then we have the Flexibility series. So those are going to be our NWA 100 and 200 series access points. And those are squarely aimed at small business. And then we have our Ultimate series, which is going to be these days the 5,000 and 6,000 series access points. And these are our SMB aimed access points. So the question becomes, well, what's the difference? Especially when you look at the data sheet or the photos and you go, these access points look awful similar to each other. So in general, the hardware is mostly the same between the 50 and 90 series. There will be a 50 series version of the access point and a 90 series version of the access point. So what's the difference between the two? 50 series is squarely aimed more at the home and small office basic user, where the 90 series is a little bit more business oriented. So the 50 series has WPA3 personal. It does not support any WPA enterprise functionality or security levels, where the 90 series does. The 90 series also has MAC authentication, radius authentication, captive portal, layer 2 isolation. So then the next question is, well, what's the difference between the NWA 100 and 200 series and the 90 series? So when you get up to the 100 and 200 series, that is our sort of true business class access point. It comes with a lifetime warranty on it. It has all of the features of the 90 series, plus it adds in the ability to do auto optimization, to do SNMP, to do dynamic pre-shared key, to do our CNP security services. Those are all added into the 100 and 200 series. And then the W series is going to add collaborative detection and response, the ability to do GRE tunneling over IPsec for wireless users, and it supports a local controller. So if you want to manage your access points and you want a management platform, you don't want to individually go into each access point to manage them, but you also don't want to use our free Nebula Cloud, then we do support local controller on the W series. And the W series access points come bundled with 1 year of Nebula Pro Pack. Continuing on here, we'll start by talking about our Wi-Fi 6 access points. So we have phased out all of our Wi-Fi 6E access points at this point. We have phased out most of our business class, our true business class, the 100 series and higher Wi-Fi 6 access points. But we are keeping the sort of Soho small business access points around. We have no current planned EOL for any of these products. It'll just depend on sales. When sales start to die off, we'll discontinue the products. But at this point, there is no plan to discontinue these. So we've got basically four models here. We've got an NWA 50AX and the 50AX Pro, a 90 Pro, and then our outdoor 50 series access point, the NWA 55AXE. So just focusing here on outdoor for just a minute. So again, we just mentioned that NWA 55AXE. We also do still have one W series outdoor access point available, and that's our heavy duty WAX 655E. Again, currently no plans to discontinue it anytime soon. So it's a more, in addition to the software features we talked about in the previous slides, it's a much more heavy duty outdoor access point. As well as being faster, offering 6 antennas versus the 2 on the NWA 55AXE. And then we do also sell outdoor enclosures that allow you to use your indoor access points outside. So these enclosures essentially, help rainproof and weatherproof your indoor access point. They also rotate the access point 90 degrees, so you can use it using that smart mesh functionality to create point-to-point or point-to-multipoint bridges between your access points. And the current outdoor enclosure we have fits pretty much all of those 50 and 90 series access points we're just talking about. And we are coming out with a new version of the outdoor enclosure for our new higher end Wi-Fi 7 access points. That should be here pretty soon. So now on to Wi-Fi 7. And again, if you have any questions, feel free to send them in using chat or the Q&A function. So we'll briefly talk about the technology in Wi-Fi 7. So Wi-Fi 7 does a number of cool new things that older versions of Wi-Fi weren't doing. So one of those things is we've bumped up the channels width. So you can now use up to 320 megahertz of channel on 6 gigahertz and 240 megahertz of channel on 5 gigahertz. They've increased the QAM from 1024 bit to 4096 QAM, giving you a little bit higher amount of data that can be compressed onto those radio waves. But where we start seeing some really game-changing things here is something called multi-link operation, which is the ability for a client device to simultaneously connect to 2 or 3 radios on the access point. So traditionally, on an access point or a client device, even if your access point had 2 or 3 radios, your client device would only connect to one of those, right? It would connect to the 2.4 gigahertz radio, or it would connect to the 5 gigahertz radio. In the case of now with Wi-Fi 7 with multi-link operation, that same client can simultaneously connect to 2 or 3 radios, so the 2.4 and 5 at the same time, or 2.4, 5, and 6 at the same time, and transmit and receive data on all 3 radios simultaneously. So this gets you higher bandwidth, obviously, because you can aggregate your throughput. And because you're sending more data at a faster rate, it reduces your latency because there's less airtime being utilized in the actual transmission of that data. And then also you get better resiliency. You can automatically switch data from different radios if one of those radios is encountering interference or poor signal for whatever reason, excuse me. The other really cool feature here is called multi-RU puncturing, and that's something all of our Wi-Fi 7 access points can do. So multi-RU puncturing solves a big problem we've had. So one of the main ways that we have been increasing speed with different versions of Wi-Fi has been by increasing the size of the channels we're using. But there's only a limited amount of spectrum out there. So you end up in situations where if you try to use a larger channel, like 160 megahertz, and there's interference anywhere across that 160 megahertz channel, it interferes with all data being sent. With Wi-Fi 7, your client and access point can automatically detect that there's interference. What portion of the spectrum on that channel you're using is where the interference is coming from, and simply stop using that section of spectrum. So it reduces the overall spectrum you're using, but you're not getting the interference causing packet drops. So you get a much more reliable connection when using these larger channels. Kurt sent in a question. Let me go ahead and answer Kurt's question. So Kurt was asking, do we know when the NWA 55BE will be available in the United States? So the NWA 55BE is a Wi-Fi 7 version of our current NWA 55AX. And the answer is we have no idea at this point. Hopefully sometime in Q1 next year. The challenge we've run into is we've just had the largest government shutdown, or the longest government shutdown in history. And during that government shutdown, the FCC has been shut down. So the FCC has not been processing FCC applications to be able to sell new Wi-Fi hardware in the United States. So because of that, a number of new products that are launching in Europe, we don't know yet when they're going to launch. The government is just starting to get funding going again, and there's a huge backlog of Wi-Fi, Bluetooth, and other devices that the FCC needs to approve. Um, so we're still waiting on the schedule from them to find out when the products could actually be sold in North America. So the plan, hopefully, is sometime in Q1, but I can't be any more specific than that. It's just going to come down to how fast approval gets processed by the FCC. Hope that answers your question. Moving on here. Let's talk a little bit about Wi-Fi spectrum, because again, this is one of the main differences here between Wi-Fi 7 and Wi-Fi 6 and earlier. So traditionally, Wi-Fi has been limited to 2.4 and 5 gigahertz. And this is a visual representation of how much bandwidth is available. So all your 2.4 devices, including Bluetooth, are all sharing this little tiny chunk of spectrum. And here in North America, it's actually smaller than what's shown here. Here it's 83, and I think in the US it's like 61 or something like that. We'll just call it 60. And then 5 gigahertz has 500 megahertz. And if you've been to one of my Wi-Fi 101 webinars, or you've just been doing Wi-Fi for a while, you know a good chunk of these channels are what they call DFS channels. Not all clients support DFS channels. So because of that, you often end up in a situation where more than half of this spectrum isn't actually usable by your client, so you can't use those channels. So 6 gigahertz now gives us more bandwidth available than 2.4 and 5 gigahertz combined. So that's why it's a really big game changer, because you've got tons of spectrum. What that means, of course, is you can use these larger 320 megahertz channels, and you can have 3 of them operating simultaneously with no interference. Or if you use smaller channels like 160 megahertz channels, you've now got the ability to use 7 of those without having to worry about overlap. Where before with 5 gigahertz, you could only use 2, and again, only if your client devices supported DFS. So it gives us a lot more spectrum to play with, faster speeds, more devices operating without interfering each other when using smaller channels. It's a big game changer. Now, some of the drawbacks of 6 gigahertz is as frequency goes up, range goes down, the ability to penetrate objects goes down. So if you're trying to just simply swap out your existing access points with new Wi-Fi 7 access points on 6 gigahertz, you may find that the coverage is not as good, or you may have holes in your coverage if you don't add a few more extra access points or reevaluate where you're positioning your access points, because the 6 gigahertz signal isn't going to cover as much ground as the previous 5 and 2.4 gigahertz signals do. The other thing to know on this is outdoor Wi-Fi 7 is restricted. So you can't just take an indoor Wi-Fi 7 access point and use it outdoors if it's using the 6 gigahertz radio. So why is that? And the answer to that is 6 gigahertz has been licensed spectrum, and it continues to be licensed spectrum for a large number of users. So rather than do DFS, which kind of screwed up 5 gigahertz, or a good chunk of 5 gigahertz for use, the FCC came up with a new thing where your access points, in order to operate outdoors, have to use a AFC, automatic frequency controller, I think. Um, Basically, there's third-party companies are providing a database of licensed 6 gigahertz users, what channels they're using, what power they're using, and the physical locations those devices are being used. So to use a 6 gigahertz access point outside, your access point has to be able to geolocate itself using GPS to report where it's physically located. And then it has to check with one of these third party companies to find out which licensed users are nearby, what spectrum and power they're using. And then that AFC will tell your access point which channels it can use and at which power levels. So it's a lot of extra technology that needs to be built into an outdoor access point. And so what you're seeing is there's not too many outdoor 6 gigahertz Wi-Fi 7 access points. But they are coming. There are some vendors out there that have them now. The AFC situation is still sort of kind of maturing. Um, but we should have some products again around Q1, starting in Q1 next year. Now, one of the ways around this is to deploy Wi-Fi 7 access points that don't support 6 gigahertz. And we'll talk a little bit more about this, but for outdoor stuff, you see a lot of these currently on the market where it's an access point, it's Wi-Fi 7, but it only supports 2.4 and 5 gigahertz. And that's part of the reason as to why they're doing that. Now, to be Wi-Fi 7, you don't have to support any specific bands. It works on 2.4, 5, and 6. It's up to the vendor to decide which of those bands to support, if any. Okay, so let's start talking about our Wi-Fi 7 access points. And I'm going to start by talking about band flex access points. So band flex is something we're doing that, as far as I'm aware, no other vendors are currently doing. So one of the things that's going on, I mentioned it for outdoors, but you also see this on the lower and indoor access points, is people are deploying and selling Wi-Fi 7 access points um, that only have two radios, usually a 2.4 and a 5 gigahertz radio, simply because it does a couple of things for you. It lowers the cost of the access point, which is important in that low end, sort of Soho segment where price is king, because you only need two radios. You don't have to invest in three radios, which drive up costs, along with amplifiers and antennas for all three. You can physically put it in smaller hardware, and you don't need as powerful of an SoC running the access point, right? Because your access point has to process all of those users and all of that data being sent across all of your radios. So if you only have to deal with two, you can use a cheaper SoC. So we are offering something different, and that is called band flex. And so in a band flex access point, you still have only two radios. One of our radios is dedicated to 2.4 gigahertz because that's what is sort of like the universal Wi-Fi standard that works with old, new, smart home, smart plug. It works with everything. It's 2.4. And then the other radio can operate in 5 gigahertz or 6 gigahertz. And you can switch that at any time. So basically, you can do like our competition is doing and run it as 2.4 and 5 gigahertz today, because realistically, there's not a lot of 6 gigahertz devices that are out there. It's primarily, flagship phones and some of the higher end laptops, and that's pretty much it these days. But eventually, a lot more products are going to use 6 gigahertz. So when that day comes, you can simply flip a virtual switch in the GUI and convert your device to 6 gigahertz support. One other benefit of you only rocking two radios instead of three has to do with PoE. So a lot of you out there have existing switch infrastructure that supports 802.3 AF, or excuse me, 802.3, yeah, AF and AT. And that maxes out at 30 watts of power. Access points, faster access points that have three radios running often need more than 30 watts of power, which means you're not able to use them, or you can only use them at half speed on your existing network infrastructure. And switches that support the new 60 watt PoE standard tend to be kind of expensive. So a lot of times when people are saying, hey, I want you to upgrade my access points, I want Wi-Fi 7, run into a situation where you go, well, your switches won't support this faster Wi-Fi 7. You're going to have to upgrade your switches as well to these new 60 watt PoE switches, and the customers balk. So using band flex or dual radio Wi-Fi 7 access points allows you to easily provide an access point that operates on existing switch PoE infrastructure at full speed. So one more reason why you might want to choose a band flex access point. I guess I had a second slide that breaks this down, but I think I've already touched on all these different reasons why you might want to use it. So to begin with, we've got our newest access points here that are all dual radio access points. So these are our NWA 50BE, 50BE Pro, 90BE, and 90BE Pro. These are all brand new. These are all available for you to order today. And the difference between the Pro and the non-Pro versions, only difference here is the Pro version supports band flex, where the non-Pro versions are only 2.4 or 5. So if you want that future proofing by giving you the option to turn on 6 gigahertz in the future, you would want to buy the Pro version. I think there's only a $10 or $20 price difference between the Pro and non-Pro versions. And then getting up into our higher end or true business class access points. We'll go through these sort of device by device. You will notice I have grouped an NWA model with the WBE model on the same slide. And the reason for that is because the hardware is essentially the same, except for maybe some memory. So all of the key Wi-Fi stats are the same between the NWA and the WBE models. Again, the main difference between NWA and WBE is things like support for local controller, support for GRE tunneling, support for collaborative detection and response, and the bundling of a Nebula Pro license. But otherwise, when it comes to the actual rest of the feature set, they're basically the same. So for the NWA 110BE and WBE 510D, these are band flex access points, so that dual radio with the option to use 5 or 6 gigahertz. And these support speeds up to 6.5 gigabits per second, so BE 6500. And all of our Wi-Fi 7 access points support MLO and these other Wi-Fi 7 technologies we've talked about earlier. From a form factor perspective, you have a single Ethernet port. It's a 2.5 gig multi-gig port to help give you the throughput to support full Wi-Fi speeds. And these give you the option, if you don't want to use PoE, you can power these using USB-C PD. So basically any USB-C PD plug that you use that provides power up to 30 watts will be able to power this for you if you don't want to use PoE. And you will notice that is a trend. We are getting away from the old barrel plug DC wall wart adapters and just giving you a USB-C port. So you can easily source any sort of and use any sort of USB-C cable to power the access points. We've already talked about dual optimized antennas, so I'm just going to skip through this. Oh, that's why it was there. Sorry, my bad. I distracted myself. So the one other difference between the NWA 110BE and the WBE 510D is that letter D on the end. So the letter D indicates that the 510 version of this product does have the dual optimized antennas that we've talked about earlier. So if you want dual optimized antennas, the WBE 510D is our most affordable Wi-Fi 7 with dual optimized antennas. The next models to talk about here is the NWA 210BE and the WBE 630S. These are both BE 12,300 class products. So in theory, the wireless data rate is up to 12.3 gigabits per second. And then the main difference between these two versions, other than the standard NWA W differences, is the S here. So this is going to be our most affordable Wi-Fi 7 smart antenna access point. And unlike the previous 110, 510, you will see here that this has two Ethernet ports. So the uplink port is 2.5 gigs and supports your PoE power. We have that USB-C power port as an option for you if you don't want to do PoE for whatever reason. But we also have a pass-through 2.5 gig Ethernet port that allows you to daisy chain your cable run to another device. So if you've got, you want to plug in a second device in the same room as your access point, instead of running two Cat5 cables or Cat6 cables to that room, you can run one to the access point and then run another from the access point to the port or to the device you want to hook up. So we've already gone through here all the what smart antenna offers for you versus standard antennas. So I'm going to skip through these slides so we're not doing them twice. So that's it as far as band flex APs. And then next, we're going to talk about our tri-radio APs, right? So these are your traditional Wi-Fi 7 access points. This is what everybody launched 2 years ago. Access points that have three radios operating simultaneously on 2.4, 5, and 6 gigahertz. So the first ones here are going to be the NWA 130BE and the WBE 530. So unlike the previous band flex models we talked about, both of these have just the standard antenna. There is not a dual optimized or smart antenna version of this. And at least in the case of smart antenna, the reason for that is the power draw. Adding smart antenna bumps up the power to the point where it's not going to work with longer runs of your standard 30-watt PoE. So that's why we're not offering it. Okay, so Kurt just sent in a question, so I'll readdress that real quick here. So the reason I've got two different model numbers up here, I've got an NWA 130BE slash WBE 530, is because the hardware is essentially the same. There may be a slight difference as far as like memory goes because the software features are different, but the hardware is roughly the same. We had a slide earlier in the presentation where I went through the differences between the NWA 50 series versus the 90 series versus the NWA 100, 200 series, and then the W series. So the W series gives us access to things like local controller, GRE tunneling, um, sorry, my mind's going blank here. Collaborative detection and response, bundled 1 year pro pack. So while the hardware is essentially equivalent, the software features between the NWA and the W series are different. But I didn't figure since the hardware is basically the same, there was no reason to create, two sets of slides for what's essentially the same hardware. So hope that answers your question. Then you asked about BE. So the BE here, this is your speed rating. So BE 11,000, BE 11,000, that's telling you the class of Wi-Fi device it is. So BE 11,000 means in theory your wireless LAN data rate from wireless user to wireless user is up to 11 gigabits per second. And then again with this guy here, we've got the two Ethernet ports. Um, some of these still have the barrel plug on them. We are in the process of transitioning to the USB-C port on these. I am so that's just going to depend. Once we sell through the barrel jack version, all of these going forward will be USB-C as well. Oops. Anyway, here at the high end, let's see if we can go back without the animation running. Yes, no? Yes, okay. Is the WBE 660S. So this was the first Wi-Fi 7 access point we launched here in North America. We beat out, I think, everybody to shipping this class of product. So it's a BE 22,000 class product. This was, I think, in North America, the first business class Wi-Fi 7 access point you could buy, or at least definitely the one in the SMB space. We beat TP-Link, Netgear, Ingenious, all of those guys to actually shipping the product. So it's a BE 22,000. It's sort of our flagship access point to this day. It does require 60 watts PoE power or USB-C power to power this guy up because of just basically how running all three radios at those speeds do for you. It has a 10 gig Ethernet uplink port, and then it has a 1 gig pass-through port on it. And you will notice here the entire back of the housing is a heat sink because of the amount of heat that all those radios and the SoC to process all that data use. But that's something, again, a lot of our competition doesn't have, which means their product's probably going to fail before ours due to heat fatigue over time. And with that, that is the end of today's presentation. I thought I had one other slide. Oh, it's not working. That's why. Okay, so that's my bad. We've got some animation things I need to fix. And I probably saw that last time I did this and forgot to. My bad. But anyway, that's our flagship guy, and that's the end as far as the organized presentation goes. If you have questions, go ahead and send those in. If you did miss the presentation, or you want to share it with a coworker, you came in late, this will be posted up on our YouTube channel, probably no later than tomorrow afternoon. And that's you can find on YouTube as Zyxel America channel, all one word. And feel free to link to us at our LinkedIn profile, Zyxel US channel. So R.W. Sanders has a question. When it comes to daisy chaining the Ethernet ports, if you're using USB-C, will the port provide PoE power? So the answer to that is no. Um, we only have PoE coming in. There is no PoE going out on those second Ethernet ports on any of the access points. So it's purely a data connection coming out. Yeah, and I haven't run one in a while. I think I'm running one next month. But if you're interested in learning more about like data rates versus actual real world speeds and why, a product will advertise itself as 5 gigabits, but when you do a speed test, you only get like 1.8. I do a Wi-Fi 101 webinar, and I'm pretty sure I've got one coming up next month, where we talk a little bit more in depth about that and some of the terms and, some of the areas that cause a lot of confusion in the way things are marketed or marked up. Um, so do think about joining that. I'd love to see you guys at that. Are there any outdoor housings for the current inside Wi-Fi 7 AP? So the answer to that is there are not currently, but it is coming. We have ordered them. We're just waiting for them to get here. But again, keep in mind legally, you can't use the 6 gigahertz radio. So if you're going to take a band flex Wi-Fi 7 indoor AP and use it outdoors, just keep in mind that FCC rules say you shouldn't be using that 6 gigahertz radio outdoors, but obviously we can't have any way of enforcing that. But those should be here sooner rather than later. Um, Hopefully next month, but probably January at the latest. Yeah, so Kurt is asking here, so you recommend APs without optimized radios to stick to ceiling only placement? Um, I mean, that's what they're designed for, right? So all those access points, the antenna patterns are optimized based on the idea that you're mounting them on the ceiling, and it doesn't matter which vendor's product you're using. So the signal sort of radiates outwards and slightly downwards. So when you start, putting them someplace other than on a ceiling, it's less than ideal, right? The signal is giving you less than ideal performance. So it's better to use a dual optimized or smart antenna for wall placements and things like that. It's if you're trying to maximize coverage and user experience. Obviously, plenty of you've probably deployed plenty of ceiling mount antennas on walls and stuff like that and made it work. It just makes it a little bit trickier than using something like a dual optimized or smart antenna. You may have to put a few more access points in there or worry a little bit more about interference between floors and things like that. So yes, that would be what we would recommend if you can. Obviously, there's a cost factor involved, and there's a lot more ceiling mount APs than wall mount APs. So the form factor or the wireless specs you're looking for may not be available. But if you can, yes, absolutely, use a dual optimized or a smart antenna for wall or other unusual placements. Any other questions? I've hit everything that's come in. Again, you can use chat or question and answer. I will see them both. Okay, I'm not seeing anything coming in, so I'm going to go ahead and end today's webinar. If you did have something you want to ask, you can always email me. My email is up there on the screen. It is seanr@zyxel.com. With Sean spelled the American phonetic way, SHAWN, the letter R at Zyxel.com. Or of course, you can just reach out to your salesperson. I'm assuming most people on this are, our reseller partners, part of our partner program. So you feel free to use Andy, David, or Jacob. And then we also have our sales engineer, Marcus, who can help for some of the more technical questions where I don't have the hands-on experience. Thank you for joining us today. I hope to see you at one of my future webinars. Um, Thank you.